Thank you.
So we lost the first 10 minutes.
Okay.
Um, but I do want to look at creating a custom symbol fill. The other type is a solid fill, and that's basically every fill in ArchiCAD has a foreground and a background pen. If you remember yesterday, we talked about like the presentation pens, like the sort of pastel pens. If you want to do a presentation plan, that's the background pen. The foreground pen is always going to be the fill pattern. So like the line pattern here has that line pattern, it has a pen applied to that foreground. Now the use with function, to backtrack to that, the drafting fill, that's really primarily just the drafting tool over here. That's just going to be 2D fills, mostly used for details or patchwork or masking fills and things like that. Um, the surface fill or cover fill, that gets applied to the surface attribute, which is the next attribute that we're going to talk about. We're going to look at creating custom surfaces. And then we have the cut fill, and that's what gets applied to the building material. Now you do have to define where these are going to be available in order for it to be applied to that thing. So if I'm creating a custom surface, I want to create a custom surface fill that matches it, and I'm going to use the cover fill for that. Um, so I do want to take a quick look at the surfaces, and then we're going to kind of circle back and discuss creating custom surfaces, creating custom fills to match those surfaces. So let's take a look at the surfaces here. In the surfaces, first of all, there are several engines. The hardware acceleration engine, that's like an internal engine. It tends to be the slowest, clunkiest, so we don't really use that very often. The basic engine is really what we're looking at. This is what it's going to look like normally in ArchiCAD when you're looking at the model. Now there is a surface color here. However, if there's an image applied, like this image down here, PNG or JPEG, this surface color is not relevant. This surface color only matters if there's no image or texture applied to it. Um, an example of not using a texture image might be something really simple, like just having a basic paint color on your wall. However, that's not going to have any texture to it, which is generally not ideal. That said, there's a lot of times when we're just going to say, okay, well, this needs to be updated in Twinmotion. So we'll just put a dummy surface in ArchiCAD and say, yeah, it's some kind of gray. So I have different variations of gray, and then update that surface, add a texture map or a bump map or displacement map or whatever in Twinmotion. Um, so texture image, the default fill pattern for that surface, if we look at wood siding, for example, is going to be this fill right here. So when you create a cover fill, if it's defined as a cover fill, it's going to be available here. And then we have the default uncut pen for that surface. Um, Now, as I go through creating a surface, creating a fill, applying that to an element, hopefully this all sort of comes full circle. So first thing I'm going to do, I'm just going to pull up a browser here. And I use Eldorado Stone as an example for this, mostly just because they have decent images. We don't ever spec this product. Um, but I'm not going to get into the Photoshop side of things, but generally speaking, we're going to actually Photoshop a tiling surface so that it doesn't have like the weird tie-dye joints when it tiles over an ArchiCAD. So you'll have to use like offset commands and things like that. But let's go ahead and pull that up in a Finder. So there's my stone surface right here. I'm just going to drag and drop that into here for right now. And you'll see like right away what that means. Like if this were just the surface, right, that's what it's going to look like over.
Yeah.
And that we don't want that. We want something that tiles out. So you would have to go through the exercise of photoshopping that. I'm not going to make you watch me Photoshop anything. I am going to resize this here in the floor plan. Let's make it like 6 feet wide. Probably be pretty good. And to create a surface, we're going to go to our surface settings. I'm going to find a stone surface, just like with the building materials. I'm just going to select one that already exists. We'll go ahead and reserve the surface settings, and I'm going to say new and duplicate, and I'm going to call this peel and stick stone. So all I've done is duplicate the existing surface in here, but I want my peel and stick PNG that I created, I meticulously photoshopped to look perfect. So I'm going to click this little upload option and add. Now this is going to dump it into the embedded library. So I'm just going to grab this right here, double check the file size. right here, 540 kilobytes, 550 kilobytes. Um, File size is actually really important for these surface images because this 550 kilobytes is being processed for every polygon that it sits on. So if you could imagine like maybe a 50,000 polygon site model, um, if you had like a 10 megabyte image, you're processing 10 megabytes of JPEG or PNG 50,000 times every time you pull up the 3D window. Um, that's not the worst thing in the world, but it's starting to get bad. So generally speaking, we want the file size for any custom images to be under 5 megabytes, ideally 2 to 3 megabytes tops. So 550 kilobytes is fine. And the reality is 550 kilobytes is plenty of resolution for anything in ArchiCAD. You're never going to be looking at it that closely that you would see any sort of pixelation on an image. But if you do create a custom photoshopped image, just double check. It has to be JPEG or PNG. Double check the file size before you add it into your model. So we're going to add that in here. Wait a couple of seconds and we'll say OK. Now I know that I resized the width of this to be 6 feet, so I'm going to say that that's 6 feet. And I have to create a custom surface here so that my elevations, my plans, my technical drawings match my 3D. But let's just go ahead and say OK here and see what that looks like. So if I grab a wall here and here, and then we'll just make this that peel and stick stone. There's my peel and stick stone right there, right? Now, if I want to define where the origin of this pattern is,
I'm sorry, Patrick. What did you click when you went into like the settings of that
yeah,
wall?
so in the settings of the walls, I just went to the model settings and the surface overrides.
And what wall selection settings, how did you get there?
Oh, Command T is the shortcut to get to any selected elements settings.
Okay,
Now, if I were to, let's say, select a roof and hit Command T, I get to the roof settings. You
okay.
can't have multiple tool types selected and edit all of them together. So I'm only grabbing these two walls. And
Whatever you select,
yeah,
it's
exactly.
okay.
And Command T will pull up the settings of that. So I've applied that here.
Got
Now
it.
I wanted to find the origin of this stone, let's say to the bottom left corner of these walls. So I'm going to go to Document, and this is like obnoxiously buried, but it's under Document, Creative Imaging, Align Texture, and Set Origin. And I'm going to click right here, and then the origin is going to tile from there outward.
Mhm.
Uh, Now another trick, just again, I'm really good at getting my cart and my horse mixed up. But this little like half dome looking tool right here is called the morph tool. The morph tool is great because you can actually create 2D vectors in the 3D window. So let's say I wanted the origin of this to be over 3 feet and up 5 feet for whatever reason. Like this is just where the origin of that wall needs to sit. I can put this in as a morph segment, grab that wall, go to Document, Creative Imaging, Align Texture, Set Origin, and click on that point, and then I can just delete that morph out of here. And now that one's tiling from that point on. That's been really useful in my opinion for like interior elevations and stuff like that, where you really need like the tile joint to line up with a specific point, center of room, something like that, where maybe it's not obvious where that alignment is based on actual model geometry. All right, but if we look at, let's go ahead and pull up an elevation here. Oh, you know what? In my marker settings, uncut elements. Why is that? Let's turn the shadow off. There we go. So I don't have a fill pattern on these walls, right? They're just showing blank because there's no fill associated with them. If we go back into the surface here, it's just this background fill. So I want to create a pattern that matches this for my elevations. So what I'm going to do, I drug this in here, I resized it so I know that this is the size that's in my model. And I'm going to take my line tool. It has to be the line tool. It cannot be the polyline tool. And I'm going to very meticulously draft out all of the 2D work here, and obviously you don't need to watch me draft for 15 minutes. But I do want to make sure that it matches the size of my JPEG. Right, so I've taken the time to draft out everything that sits over the top of this, and I can double check that that's tiling the same as the JPEG. And I'm going to copy this line work to my clipboard. So that's Edit Copy or Command C. I'm going to come up to my options and fill types. Let's go ahead and reserve this. We'll create a new one and we'll call it O4 Peel and Stick Stone. And we need to make this a symbol fill. Cannot be a vectorial fill. We have to check the symbol fill and we'll say OK. And then we get the option to paste in that clipboard line work as a symbol fill. And then the third part of this, so create a new symbol fill, or draft the line work, create a new symbol fill, copy and paste it into here. Zoom out and make sure that it's available for a surface setting. This is never going to show up in a cut fill, so we can uncheck the cut fill. It's okay to use it, leave it as a drafting fill. Now I can see right away that the stroke pattern of this is not does not match. It's 3/64 of an inch off, which could be problematic over the length of a building. So that's just me not being precise enough as I was drafting that out to match the exact length and width of that pattern. But I would want to be more precise and make sure that it matches. This little thumbnail right here is literally just like the preview right here, what's going to show up. I used to be super anal about like trying to find a pattern that matched what was going on here. It doesn't really matter. It's really just an identifier. So other than that, that's really all there is to it. If you had something like, let's say, a tile pattern where it was just really a grid, but maybe it's some like specific size, the easiest thing to do there, rather than creating a custom symbol fill, just duplicate one of these. Let's say it's 00 grid 4 and 5/8, right? And then from there, all I have to do is make this 4 and 5/8. So duplicate an existing if it's a simple vectorial fill, but we'll probably have to create a lot of custom fills for different tile patterns, stone patterns, whatever. Now we'll go ahead and say OK, and we'll come back into our surface settings here, and we'll have that available here as a new surface. And this is where yesterday when I was saying like depending on the density of the pattern, you might want a darker or a lighter pen, and that's going to be all of these pens right here, the pen 51 through 60. So let's go ahead and make that like a medium dark pen and say OK. And now when we come into the surface settings, why is that not showing? Oh, maybe that's it. There we go. So now I have that fill pattern on that wall. And because it all pushes it up to the positive quadrant, if you think about like an XY quadrant, the origin for this should match the origin for the surface in 3D, as long as they're the same exact size and scale.
Hey Patrick,
Yeah.
is there a way to like load a file for the surface pattern as well? Like a line work file or something, or does it just have to be traced line work from the file?
If you had, let's say, a stone manufacturer or tile manufacturer that's providing DWGs for tile patterns,
Mhm.
you can drag and drop a DWG into here and explode it. There's a feature, edit and reshape and explode into, where's that? Explode into current view.
Mhm.
So if they have their own line work, you can drag and drop that, explode it. As long as it explodes into lines and not polylines, you can copy and paste that in. But you
Mhm.
cannot load a DWG as a vector file into the surfaces directly. It does
Okay.
have to be line work that's on your clipboard.
And would you
Yeah.
recommend like sandboxing that first or like opening it in a separate file and bringing it in, or it's
For
fine to just drag it
DWGs,
in?
not really, because if you had a DWG that you just drag and drop, when you explode it, it converts all of the layers to the ArchiCAD layer by default, or it gives you an option
Hmm.
to either incorporate the layers or add everything to the ArchiCAD layer. So it's not going to pollute the file horribly. Sometimes it'll bring in like line types and fill types, but not generally for DWGs. It's really just for IFC or even oddly enough, copying and pasting from one ArchiCAD file to another. It's good to do that in a sandbox file just to make sure that you're not bringing in all of those polluted surfaces that we talked about at the
Hmm.
training lecture yesterday.
Okay, great.
And if you do end up seeing, let's see, do I have, let's see, does this one have? Well, there's some in here. The like the Elmo, these italicized surfaces. If you do have those in your project, that's going to indicate that there is pollution in that project. So if I were to copy even just like a basic line segment from this file into another file, it's going to bring those surfaces with it. That pollution is like super toxic, super
Hmm.
volatile. It just drags around every file. So it's something to keep an eye out for. Mostly, it's just really annoying if you're going into your surfaces and it's severely polluted. You're going to have like sometimes 500 or 600 surfaces that you're never going to want to use.
Hmm.
It doesn't necessarily affect file performance. It just
Hmm.
affects the ability to find the surfaces that you need quickly.
And is there like a purge command or something to clean things up?
Unfortunately, it's a little bit deeper than that. You have to go to the library manager. You have
Hmm.
to dig through and find that polluted surface object, which is going to be it's going to be called master underscore GDL.gsm. It's and there's
Hmm.
usually a series of them. The red flag is if there's a folder in the embedded library that says from 2011-01. However, I've been seeing that those objects are appearing in all sorts of random places in the embedded library. But you do have to clear those master GDL parts from the embedded library. And then when you go into your surface settings, you can grab them from here and just hit delete and
Hmm.
clean them out. But if you just delete them from here and you don't get rid of the master GDL parts first, they're just going to reappear.
Okay.
If I pull up, I think Woodside was a particularly bad one. In Woodside, I think I found. In the library manager there was yeah, so here's that from 2011-01 folder. That likely has, actually that doesn't have those parts. However, I believe that one of the modules did. Yeah, so this is an issue, like super deep issue. I can't delete them because they're part of a module. We're going to talk about modules, I believe, on Friday. We're going to talk about placing the building into the site as a module. But the module has its own library. If the module contains these master GDL parts, there's really no way to get rid of it other than purging the module out and replacing it, which means you've got to reposition your building. But this is an indication of like really bad pollution where there's just all of this stuff that's coming in. So definitely, if you see this in a file and you want to copy a detail from it, copy it to a sandbox file first, clean up that sandbox file, and then copy and paste from there into your file. And it's literally not even just like 3D surfaces. If I grabbed like a 2D line or something or a text box or something, it would bring that in with it. Any copy and paste from a polluted file brings those surfaces. Okay. Um, hmm. If you ever think that you might need to adjust the surfaces later, you can take this stuff and put it onto, oh, and Command T is to get to the element settings, but you notice that this is only going to adjust the figure that I have. I also have all that line work selected. So if you hit Command Option T, you get Edit Selection Set. So here you could put this stuff on the temp hide layer so that you could go back through and edit it later on if you ever had an adjustment that you needed to make to that fill. That's really what that layer's for, is for creating custom objects, custom surfaces, custom door leaves, things like that. It's basically just hidden in all views. Okay, so building materials, fills, composites. We can also create custom lines. I don't think we really need to get into the weeds on that because there's just so rarely a case for creating custom lines. Um, It's similar to creating custom fills. If let me reserve that. If I wanted a line type that matched that fill, for example, I can say peel and stick stone, make it a symbol fill, say okay, and paste that in here, and it's going to create a line type from that. The line type scale is always a little bit wonky. So like when you see stuff like I believe that at one point there was like an insulation fill in here. I think I've since removed it because it was never at the right scale. And it's really just not that useful. It's not that great of a way to show insulation and details. But if there are like specific utility line types, you can draft out that line. It does have to use lines. You can't use text. You can't use polylines. But you draft out the text type that you need and a line type, and you create that, copy it, paste it into here, just like you would for the fills. If it's a basic dash line type, you can create a new dash line. Let's create a dash line here. Um, and then you can add up to 6 different dashes and gaps. You can even like graphically adjust them for their different widths, or you can set the dash and gap width here. So I don't know that there's a lot of call for that, but if you ever do need to create a custom line type, it's pretty simple to do. Um, all right. The next thing, and I think we'll probably have just about enough time to get through it all, is the complex profiles. I want to talk about complex profiles on beams versus walls and why we prefer beams. I want to take a look at applying like trim profiles as well as like custom steel profiles. There's a lot of different options there. The complex profiles are one of the more flexible and versatile tools in ArchiCAD. If I go to complex profiles and profile manager, it brings up this palette. Unlike the other attribute managers, this thing can actually just be up. It doesn't keep me from working. If I had the surface editor up, for example, I can't actually do anything in the model until I say OK or cancel. But here, this palette can just be up. I can see what profiles I have available. For example, like the SD base cabinet. If I just draw a beam in here, I can select that beam and apply that profile. I actually really like the complex profile as sort of a schematic level modeling tool for things like cabinets. It literally is just an extrusion of that shape. Whatever you draft can be an extrusion. If we look at this profile, if I click edit here, there are options for, I have to reserve, for adjusting certain dimensions of the thing. So for example, like there is this counter overhang. Maybe I want to be able to adjust the counter thickness. I can do that. I can add a parameter here to say counter thickness, and I want to adjust from this point to that face, and that's 2 inches. Let's go ahead and save that and close. Now I can see that I have a blue line here. I can actually grab that, and on the pet palette, I can adjust that down. Additionally, it gives me settings within the segment for the profile modifiers. So maybe my counter thickness is 7/8 of an inch or something like that. I can actually type that in here. Or maybe it's got a super deep counter overhang for like a knee space. So I can make that like 18 inches. So that can actually be modified individually. It doesn't have to be modified globally within the profile settings. For something like, I don't know, let's say like we've got like a historic preservation project in San Francisco, and we've got a built up crown molding or something like that. Something like the Arthur Washington project had a lot of that. So I'm going to say, uh, 1 second here. I'm going to create a new one, and let's just put this on. Sorry, I'm getting sick, I think. Let's call this AI crown molding. Create that. I'm going to grab all of this and just delete it. Here's my origin. That 0, 0 point is going to be that gray X. That's going to be your reference line for complex profiles. So I'm going to take my fill tool, and the fill tool is going to give me my building materials, right? The building materials are the cut appearance of things. So I'm going to make this trim. And let's just start with like a ceiling plate, and we'll say that this is X. 5/8. So there's a ceiling plate. Maybe it runs down the wall. I'm not gonna, again, doesn't benefit anybody to watch me draft all day, but just want to get something in here. And I'm just using the split command for this. It's backslash. All right, so if this is my built up profile, I'm going to eliminate these modifiers. If you need to add a modifier, I can say that this is going to be my ceiling plate depth, and I'm going to modify from this point to this point. So that's going to be an adjustable parameter. Here I have that use with function, just like with the composites. So this can be used with walls, beams, columns, railings, or it says library parts, but really the library parts means curtain walls and stairs. In this case, I do need this to be like a vertical component at some point in the room. So I'm going to say that it's going to be for beams and columns only. Actually, let's go ahead and say for walls, just so I can show an example of why we use it for some tools and not others. We'll go ahead and say OK on this. We'll close out of this. Let me grab a couple of beams here and apply those. And I'm actually going to even grab a couple of walls and apply them as walls, just so you can see the difference. So select those and say apply here. Now, if we look at these together, right, they look pretty much identical. The difference is with the walls, they're not mitering together in the corner. They're trying to find where they cope. So basically how they join together. So if we look at just this beam and this beam, right, I'm adding all of these extra polygons for this curve, how that copes to the other one, as opposed to the beam where it's literally just a 45-degree cut or whatever the angle would be that would bring those together. So it's always preferable to use the beams over the walls as a complex profile. Years ago, I did an audit for this guy. He was just a design build guy doing kind of really basic models. He really only had like a roof, a handful of walls, and some exterior trim on his model. I think his total model was like a couple 100,000 polygons. And he sent me the file because he literally couldn't open it without it freezing up on him. And I found that his soffit was something like this, where it was just a soffit. It was just sort of a bit of crown molding, ram's crown or something like that. And he had used walls to model that. And replacing those walls with beams went from being a file that crashed every time he opened to just a regular normal running file. So I think that that's kind of an extreme case, but it is an example of the dangers of using the complex profiles for walls. I have seen people use complex profiles for like canted walls with siding and really kind of almost drawing a wall section with the profile and applying it to a wall. That has other issues in terms of plan, graphics, cut line issues. It's better to build the walls up out of their various parts and components than to just draft a detail and extrude it around the building. You'll find that it's difficult to get every single condition clean. Generally speaking, I kind of applaud the use of or the technique of modeling as much detail with as few components as possible, but there's always a breaking point where like sometimes less is just less.
So those are both beams? Is that what you're?
This is a beam. This is using the
Yeah.
beam. This is using the wall tool.
Okay. And so that's for crown molding, but what about baseboard or casing or,
Yeah, same
same.
concept. So here, if we went new and we'll duplicate this and we'll call it baseboard, right? So that 0, 0 point, that is the reference axis. So it's likely that, so I put that at the top here because if the beam needs to move or if it needs to resize, that's already at the ceiling. For a baseboard, it probably needs to go from the base upward. That reference line probably needs to snap to the floor finish. So if we eliminate this stuff, maybe it's got like a half round base shoe or something. Yeah, let's just put like a cap as well. So if that's my base profile, we can go ahead and save that. And okay. And we can apply that here as well. Oh, geez. Sorry. So what you'll see is that reference line right here at the top. When I apply this to the beams, it actually inverts because that reference line is the fixed position, just like with the walls or any other beam. That's the fixed position. But this would allow me, like if I set this beam to 0 to project 0, I don't even need to be in 3D now in order for me to apply that beam into my floor plan. I know that it's at 0 here. I can just draw it around in floor plan to the face of the wall that I need it to attach to,
Mhm.
right? So now if I look at those walls and that slab in 3D, oh, I think, was I on the second floor? Where did I put that? Oh, I thought I set that to 0. Anyway, that would be the idea, is that I would set it to 0 before I drew it in, and I would know that that's there. Or if I knew my ceiling height, I could do the same thing with the crown molding. If I knew that my ceiling was at, let's go ahead and put the crown molding on here, right? And I knew my ceiling was at 9 feet or whatever, I could draw this in as crown molding. Right, and then that's going to be right at my 9-foot mark.
Mhm.
But this is also another example of like not just getting tunnel vision and focusing in on a single view. Like go ahead and cycle through a building section, interior elevations, 3D, whatever other views you need to sort of verify that this is in the right spot. Because it might be that this room isn't a 9-foot ceiling, maybe it's a 10-foot ceiling or a 9'9" ceiling or whatever. Okay.
Mhm.
All right. Other things about the complex profiles. I don't know how useful a lot of this will be, but like, let's say, for example, I needed to be able to snap something to the end of this beam at this point. If I come down here to my hotspot and add a hotspot here and say save, and close out of that. And if I go into that beam now, I'm going to see an additional hotspot right here, in addition to the sort of 4 XY coordinates. It's going to add a hotspot here at the end. It just gives you something to snap to should you need it. Additionally, let me make sure that I'm not using any surface overrides. So we do use a lot of surface overrides at the element level. For complex profiles, that's oftentimes not the best way to manage them because it could be that I need this base shoe here to be a different color. And the surface overrides are really going to apply that surface to the entire element. Whereas if that base shoe needs to be a different color, I can select this thing and where's that? Oh, here's the finish core other, like we saw with the composites. We do have that control there. I can override the surfaces of this thing to be red, for example. And save that and close. And then that part of the profile is red. Um, Additionally, we can even get into a lot more detail. Like if I wanted this curve to be a different color, I can even select just that curve and say that that curve is green. Oh, if I can type, there we go. And again, I don't know how useful this is going to be. I haven't necessarily seen a lot of people kind of painting different surfaces on a profile, but you don't have to have that whole profile as one surface. You can really get in there and like build this up out of separate pieces and apply different surfaces to different parts of the same beam. And again, that's that balance of like how many different elements do I actually need? Can I model this all with one? This baseboard would be, no matter how ornate it gets, it's going to be the same baseboard around the entire room. So it doesn't make sense to build it up out of separate beams. Like just make it one profile, and you can make it show up however it needs to in that profile. All right. The last thing that I want to get into, I always say the last thing, and then there's always something else. But the last thing that I could think of right now is the import standard steel profile. So this would be, if we get a steel beam from an engineer and they're not doing their own IFC model, sending us the BIM model for us to incorporate, we actually have to incorporate steel into our project. There is an option here to import standard steel profiles because this is not a US built software. They
Is that common for our consultants to have their own BIM model, or do we often just draw what they've done in 2D?
It's getting more and more common, especially with structure and even with mechanical, electrical, plumbing, MEP guys to send us their IFC models. There's a whole IFC exchange protocol that we're going to talk about, I believe tomorrow. Um, so yeah, it's very common for them to be modeling things. It was not that way even like 5 years or even 3 years ago, but anymore, there's very few people that we work with that aren't doing their own modeling in Revit. Um, but it does come up, and sometimes actually some project managers and some job captains even prefer to redo the structural model in ArchiCAD as a way to sort of wrap their head around the structure and make sure that it makes sense with what our design intent is. To me, that's like it's a slippery slope of like just taking on liability that we don't need. If we're like, oh yeah, that beam fits, but we've shifted it over a quarter of an inch from where they have it dimensioned, suddenly like we're stepping on toes, they're stepping on toes. It gets built one way, and we've got to like scramble to come up with something during construction administration. It's come up before. It's happened before where we like I think it was like actually an outlet was shown exactly where there was a column, and there was just a conflict between our model and their model that we didn't catch until we were under construction. So it's better if we can incorporate their model and catch those sort of conflicts, those collisions ahead of time. Um, anyway, so the steel profile, it is actually common for us to model exposed steel. So if we have like steel columns, exposed steel beams or rafters, if it's exposed, generally we're modeling that because we want to have control over the appearance of that thing. If we bring in an IFC model from a consultant, we have less control over what the surface appearance of that thing is, or even sometimes the cut appearance. So if it's exposed steel, generally we're sort of either recreating that or taking ownership of that, but not always. Anyway, what I was saying about the naming here, it doesn't call them wide flange beams. It doesn't call them I beams or whatever. It just basically gives the name of the shape. But the actual profiles, the W whatever 1499, this is the actual size of that beam. I've yet to find a profile in here with the name that doesn't match the actual industry size. The thing that we do have to worry about are that the tolerances for a lot of steel are to the 64th, but as you probably know with rough steel, it's generally not that uniform.
Mhm.
So if I'm importing a profile and the height of that profile is like, let's say 9 and 63/64, I'm usually stretching that to 10 inches. And I would always bump it up a little bit to make sure that I've got some breathing room there. And that mostly is just to ensure that we're not dimensioning something vertically in our model to a 64th of an inch. I guess it's up to personal preference on how precise and detailed we need to be with our model, but generally we're not going to be showing 64ths of an inch in our dimensioning. Um, and we just want to make sure that we have the breathing room we need to get that steel in there. So again, it's less and less of an issue as more of our consultants are doing their own modeling. But if I did want to import one or more of these profiles in, I just select it from the list here. I make sure that I'm using the correct building material, and I say add to project and import. Now in here, I'm going to see, should be underlined. Which steel was it? Oh, here we go. W14/99. So it doesn't come in just default usable. It's going to be using some of the wrong pens. It might have the wrong reference line. So if I click edit here, notice it also has all of these hotspots. We're probably not going to need to snap to all of those points. So I'm just going to grab all of them and delete them. Also, that boundary pen for this thing needs to be the structural pen is 142, so we'll apply that. Um, Applied to custom edges, so that's now going to be using the correct pen. Also, there's the reference line here. If this is a column, it's probably okay for that reference line to be in the center. If it's intended to be a beam, I probably want to shift that down so that I'm actually putting that beam reference line at the top of the beam, so that if the beam size changes, it's growing downward instead of outward. And from there, let's see what else. Oh, it is a core element. I don't want it to be able to stretch. This is a specific beam size. The other thing about this is it's pretty low level of detail, right? Like an actual steel beam is probably going to have like a chamfer here and a chamfer here. Um, it's actually better if it doesn't. Again, just trying to put polygons where they're important, and for an exposed steel beam, having those chamfers is probably not very important.
Mhm.
If it is, if it's like a really big chunky piece of steel and we want to see that in the rendering or in the elevations or in the section, certainly we can add it, but just be sort of aware of where we're adding polygons. So now we'll save it. We'll say close that, and I can apply that here. And then the other thing about the steel, or the complex profile. So I put that reference line right here at the top. When we were looking at the beam and the column tool yesterday, there's this little reference axis. You cannot edit the reference axis of a complex profile in the beam settings. It's fixed by the profile location. So if I needed this to be, I don't know, maybe it's a porch beam or something where it's actually set at the bottom height for headroom. Um, if that reference line or the beam potentially needs to grow upward, I can shift this up to here and save. And now that reference line is at the bottom of the beam. Okay. Any questions on any of that? Okay. With a lot of these things, like the beams and the columns in particular, if I were to, let's just dump a column in here and apply this. Um, if these two things need to miter together, for example, there is a tool in ArchiCAD for that. There's a feature of the beams and the columns where I could say this end is at 45 degrees. And this end is also at 45 degrees. So you can actually create these miters directly in ArchiCAD. There's no need for like complex solid element operations or anything to trim those together. Um, Another thing about, let's take a look over here at these ones. About those modifiers that we were looking at, if I have a modifier on this piece and not that piece, so let's say I pull this back to here, it may affect how those two things trim together. So I could see now that this piece is not trimming together with this piece because I've modified the depth of that piece. It just gets kind of wonky. So it's not always a perfect solution to have those modifier components in here. Um, this has actually come up for flat roofs with a deep overhang where the overhang was different on different elevations. We couldn't just model it with a single complex profile. We had to actually build it up out of individual components in order to avoid those sorts of weird missed miter conditions. All right. Well, I am going to stop the recording. I'll get that uploaded. I'll get you the playlist. I did upload yesterday's video. So I'll get you that playlist so you can go back and reference if you need to. And then hopefully I can see you at the roundtable discussion here in a few minutes.
Yeah, I
Thanks,
want to tell you,
Patrick.
Patrick, I my schedule keeps getting filled, so I think I have
Yep.
more time today to work on my model, and I hope I have some better questions for you.
Okay.
Um, but yeah, I appreciate your help, and this seems to be a thing. Everyone can access everyone's calendar, and then they start
Oh
filling in.
yeah. Yeah, well, especially in the PM role, it's always a struggle to find time as a PM in new hire training because it's not just learning ArchiCAD, it's not just learning the
Right.
Office
They
suite,
have all
it's
this other stuff.
everything. You're gonna get packed. So,
Yeah.
um,
Okay.
honestly, Kelly, like if you come out of next week just having a better understanding of like moving walls, knowing that when you make changes to the model, what the sort of fallout of that is, and just even just the base confidence to know, okay, well, I can start massing out or doing some schematic studies. I don't think anybody's expecting a PM to jump in here and start cranking out window and door details. It's mostly just about being involved, and when you have a D1 or a job captain working under you, not being like, hey, can you send me a PDF of this? And then cutting into their day a couple hours to get that if you can jump in and look at it yourself.
Right. Totally.
Like being involved in the project and the ArchiCAD model, not necessarily like actively authoring stuff in ArchiCAD.
It seems between AutoCAD, Revit, and SketchUp, they're just different words and
Yep.
similar tools. You just have to learn the right words and where to
Yeah.
find it.
Yep, it's
And
a lot of it is just like little things like, oh, I need to see this condition, right? So I need to see what's going on in this bathroom, but I can't get into that bathroom because if I try and navigate into there, it's little things like this. Like if I try and navigate into here, it just ends up like kind of choppy. So knowing
Mhm.
things like, oh, if I put a marquee around here and make that a bold marquee and F4, like how do I actually work and look and see what's going on in this room?
Right.
Little tips like that, like just being able to jump in, make a cut, look at what's going on, give feedback to the design team.
Yep.
So,
Awesome. Thank you so much.
all right, guys, we'll catch up in a few.
Well, see you in a bit. Bye.
Bye.
Bye.